Hello, friends. So today we will be talking about AI evolution. Uh, Many of you got introduced with AI when ChatGPT came, right? And then you start thinking, okay, there is an AI, there is something called AI, but that's not true. The work in the computer science is going from the last 70 plus years for making AI what it is today. Okay, this is not just the ChatGPT time when we have some kind of AI. So we will see in this video about how the AI is evolved and what are the different types of AI, what are the different milestone when things got changed completely for the betterment of AI. The journey in the 17 in these 70 years is not this in a straight line. Sometime the speed got very high, and which is like today. The progress has not been made in the last 70 years as fast as today. This is, I think, the most super fast speed with which AI is evolving on the daily basis. There is something, and God knows what will be the next. Not actually God knows, people knows what they are working, but definitely there are, if there is something very major uh, change happen, then definitely it just God knows. Okay, so let's come to our point. Here we will talk about what are the different phases, right, and how we are started machine started learning, right, how this the concept of AI started first, and then neural networks, the complex patterns which is emerging, and then we have transformers. I think attention all we need. That's the Google's paper name, which basically evolved this transformer architecture, and with which NLP exploded in proper LLMs. And this has also helped in computer vision. um, a lot of changes has happened, and multimodal, which is vision LLMs, VLLMs are also came, right. And then the recent age of agentic AI, how the assistant and agents are changing how we work, how we think, and also it has changed, I think, everything in all the aspect. So it's a long journey. We will cover everything in this. This is just a glimpse of that particular thing. Um, but here we will talk about each phase in detail, and also what was important in each phase, and why it took so much time for AI to come to this level when other fields in computer science has evolved at a different pace. Okay, so first era was 1940 to 50s. Right, what was happening? Many of us not born during that time. India was getting independence. Right, so much things was happening, and there was no concept of computer. Right, but people were developing some machines which can have intelligence just like a human. But that time it was far fetching. It was only mathematical understanding during that time that people were developing. So they have developed the mathematical concept of neural networks, neurons. Like they have understood in the brain how the neuron work, right? How the logic works in the brain, right? That was a phase when we were just thinking those ideas, whether there can be a machine which can think like a human. Okay, and then there is very good, very famous researcher, Alan Turing. He developed a Turing test. So what is Turing test? Turing test is basically test for the machines, right? Test for machines to check whether that machine can function like a human. They can think. Can they think? right? So that was a there was some test cases developed, right? Even today, like if you see, whenever there's a new LLM came, they claim this is the best model, right? Or they claim a particular model has a higher intelligence. On what basis they are saying? So there are some basically benchmarks, test cases in simple form people create. There are some researchers who create only such test cases, so that whenever a machine is given that kind of questions and if they solve correctly, then we can say the machine has achieved to a higher level. Nowadays, you are thinking there are some coding agents which are coming, right? So, and there are some models which uh, have a higher percentage of solving maths problem, right? And all these benchmarks are created, and these benchmarks are also evolving because now models and intelligence is increasing, right? Neural networks has been developed. They have higher capacity. So these test cases also need to be evolved so that they can judge a program or a machine whether it is what is the standard of that particular machine, right? Whether it is achieved a actual intelligence. That's why, like you might have heard about the AGI, right? Artificial General Intelligence, which is basically create a machine which can act just like a human. Human can think, human can adapt. Human when focuses on a particular problem, they can think about it, they can reason about it. They just not only focus on one domain, but they can interlink different domain, right? So that's how this is a very big project which even many companies are trying, right? So Google, OpenAI, all these are trying to create an AGI, right? All these neural networks, and then is a the step toward it, right? But it's far from now. Maybe we'll talk about some interesting story later also. So this is how 1950s these things came. But you are wondering, right? In 1950, when there is a no concept of computer, there no concept of algorithm and all. How people are thinking about this? It is only on a mathematical modeling, like theoretical computer science, basically, which was developing, right? And then in it was in 1956 in Dartmouth conference, they officially launched AI as a research field. Before that, AI was not a field. It was just they were thinking of creating some machine which can think like a human. Okay, so and that idea of learning intelligence could be described during that time, right? So you might have seen in when computer came, right? We have some kind of algorithm, we have some kind of making some code work, right? And if you might have heard about computer languages, there are some low level languages, high level languages, right? So during that time there was no concept of high level languages, only the low level languages, which means Fortran and all such kind of languages, right? So during this era, what was the one question? Can intelligence be described so clearly that a machine can imitate it? Like whether a machine can act as an intelligent machine. So that was a hypothesis or problem that people were creating, and which led to the emergence and work toward building an AI. Okay, so here what was happening? Machine was no longer seen as a calculator. Like before, calculator is what very fixed few numbers it can add here and there, some calculations. That was the only thing that a calculator could do, right? And then we were thinking whether we can build some system where which can reason, which can learn, and which can solve problems. So after this you will see basically how computers started developing some algorithm or rule based systems. So basically this was a symbolic AI and rule based intelligence, which started during the 1950s and 70s. We started working on logic, right? So when you develop any algo, right, like we talk about, let's say, different types of algorithm, like bubble sort or searching algorithm, right? there are so many data structure, and all that data structure is to create a better algorithm, better logic, so that how we store the data, how we retrieve the data, which can be done in fast way, in fastest optimized way, when we have large amount of data, right? So that was a time when things were started developing, that yeah, so logic was developed, right? And then rules were written. If this is true, then you do. If this is true, then you do this. If within this there can be condition, then this is true. Then these are the option. Then to go this way. So basically, all these rules were developed, right? And at the leaf side, we have some rules, right? There can be something like this, right? So we will use some rules and whatever fits, and we will use that, right? It could be considered as intelligence, in very simple form, right? A child, we can teach the very small kid that you pick a ball and then throw this way, right? If it comes from left side or right side, then throw it in opposite direction. These are simple rules. Similarly, machine were taught with if else blocks, so many conditions or heuristics, basically, that there isn't some kind of intelligence which is available. We have developed some search algorithm because there are some common problems like search, sort, store the data, retrieve the data. These are the basic problems during the early days of computer science, right? And then human knowledge. So computers, what it does, it's just a machine which solves some kind of problems of the human, right? So whatever the logic that we are writing, it is encompassing human logic. And then some definitely domain knowledge. If it is a problem is solved in healthcare sector, then there's some health related or medical science logic need to be involved, or there is some production which is happening, of some manufacturing is happening. Those logic will be there. Those human knowledge is represented in the form when a computer can understand, and it can make some decision, it can show some kind of intelligence. We developed some kind of chess programs. Why the chess program? Because if you see, chess is a board game, right? So there are many types of board game, and it involves some kind of intelligence. So there are like eight, considered this is eight rows, eight columns, right? And then whenever a player is here, um, then it can move in this direction or this direction, or back, right? So there are certain rules, and at any point there can be n number of decision which can need to be taken. If a person pick one option, and then all the position of the board change, and other people who are playing, they have other options, right? So there can be a huge tree like this, right? There can be some options under it, there can be further option, and under it there can be further option. So huge tree will be created. Now at times this is exponential. Normal algorithm or with proper data structure, this can't be solved. That's why we have to develop some kind of heuristics, right, during the initial days, or some kind of reasoning, rule based, or they have some important knowledge of that system. All those rules are coded, because in chess, because we have taken the example of chess. In chess there are some players, right? And these players can have different types of rules for playing, right? So the rule-based chatbots, theorems were proving, we were planning something. Again, all these were effort for building some kind of logic, rules, representing human knowledge, for bettering our machines to mimic the human intelligence, right? So symbolic AI was powerful in controlled environment. This is important. When we take one type of problem, it become controlled environment, right? We know how the what are the different players within that, right? And what is the possibilities. Rules are already clear, but in normal human world, it is not controlled. There can be n number of factors. Whatever factors you pick, there can be some plus one plus five new factors which may emerge, and it's very hard to consider all those basically factors and build some rules. That's why real world is very messy, and these systems can't work, right? That's why before there's some specific algorithm which can solve a problem, but in a particular environment for particular type of problems. But this phase basically gave at least some kind of representing human knowledge into a form where a machine can understand, right? Or building some kind of rule based reasoning. They also build some kind of search based problems, because search is one of the basic problem every human being is doing, or any particular field or any logic that you write, there has to be some kind of search, or some kind of shorting, or some kind of very small basic problem. These fundamental problems, when we solve, like we can solve a bigger problem, right? So some kind of expert decision system. So this was a time that we were at least um, able to solve these type of the small problems during that time. Okay, so after the rule based systems that we were studying here, right, the winters came for AI, which means basically winters is when nothing is happening, right? You go to your bed, just pull your blanket and all. So because the expectation failed, machine were not able to learn faster. They were not able to solve the real problems in uncontrolled environment. They were able to solve some basic kind of problems only. So during 70s to 90s, not much things happened, and there were some real problems. Why? Because computers were weak. They were not able to represent a lot of compute. They were not able to do very fast work. Where they were slow. Data was limited. In order to learn about the system, data was limited. The AI picked up when there's an internet, there was a lot of data was generated in a machine readable form, right? So there are some books, but those were not readable by machines before, right? There were some images, but those were not actually given to can't be given to computers, or there can be there was no some basically tabular form of data. All those are in notebooks and books, right? It was hard to give that much of amount of data. Memory was also not that fast. When I was in college, my professor used to say in IT Roorkee that they they have used computers in computer lab. They were punching card basically. They were coding something on that punching card and then assigning the job to the punching card to the computer. It was a big, huge computer in a whole room. Those type of big machines used to come before, and that the small code used to run for weeks, or if not like days and nights, right? And then they were going back during the evening, or the next day, or after a few days, and collecting their jobs. And then there was some queue for different people, different researcher, to assign the job to the computer, because there was not so many computers, right? So those type of things were the challenges, right? Computer was very weak. They were not available just like we have nowadays. Every person has kind of one laptop, like whoever can afford, um, so they can do some kind of work, right? But that was not the time. During this time, nothing was this, right? That failed the expectation how the AI can learn, right? There was some rule based systems was very brittle. Means in a particular environment it can work very fast, very correctly, but as soon as there is some another factor which comes in, it become very hard. Okay, so expert system were hard to maintain because the knowledge change or some heuristics doesn't start working, or like there can be some rules, right? A rule breaks, rule change, then those type of systems failed. AI worked in demos but failed in complex reality. And then this is reminding me, even today is when we talk about AI, right? We require GPUs, and GPUs are costly. Not every computer has a GPU, at least at this point of time, right? There were some in the cloud. We have machines, right? We can assign our task, and we will be built only for during that time, right? It's just similar to kind of that big computers, and we will be paying for our job, and then our job will be done, right? Those are the things. So these complex AI agentic systems, even if you see today, many companies complain AI hallucinate, or there are certain challenges. Context is not proper. That's why AI is not performing to the expectation at times. Um, so these were the challenges of before also, but problems basically solved. Like people will use some kind of techniques to solve these problems, and these will get solved definitely. And even today, agentic AI has started solving many problems. There are different types of techniques getting developed, different patterns, right? So some solution will be evolved. So during this time, intelligence can't be built only by writing rules manually. At least this is was established. But because computer got basic understanding, so they understood some kind of rule based system can work, right? So after this, if you see, right, so this says writing rules is difficult, but machine learn can learn the rules from the data. First, we were giving rules, right? That was an effort, but then uh, problem change, learn the rules from the data, right? So we have our job becomes to collect the data. Um, okay, and during this time, so there was one phase with which was developing some kind of algorithm, a basic which can computer can work, right? Rule based systems. We have, and I guess whoever prepare for the interviews, they prepare for DSL Go, and they knows how difficult the algorithm could be, or different kind of databases or data structure could be to implement, to maintain, and each solve one particular specific problems, and they are good at it. But at times it sucks for other types of problem. So this is the way it works. But during this time, right, in like the previous centuries, at the end, machine learning was started taking over, because we ignored, we will not write rules, but rules will be learned from data, right? So this was a shift that happened. And during this time, we started working data driven systems. We started collecting data. So in the traditional machine learning, right, these are the different types of algorithms. There are many more than this, but regression and logistic regression, decision tree, naive Bayes, right, all these kind of type of algorithms we were developing. And the objective of these algorithms was to collect the patterns from the data. So effort was first collect the data in a particular form, and then um, basically learn about the pattern. Okay. For example, here is an example. In today's time, you might have seen your Gmail or any mailbox identify a particular mail could be a spam, right? Because it is learning through the patterns. But during that time, through the traditional machine learning of this, right, what was happening, there was if somebody contains some kind of rule, right, if it contain a free money, then it could be spam, right? But this is rule based system. But was this allowed? Because if a machine or basically an email provider is reading your emails to mark a particular email as a spam, this is privacy concern, right? It can read anything and then it can pass that information to someone else. So people can't read the information. People can't basically, and those rules can't be applied, right? But later on, when machine learning came, we were given a lot of emails which were spammy, and we were given a lot of emails which are not spammy. So then machine try to learn, or the model basically using some of these type of algorithm, it try to see whether a particular email is a spam or not, and it categorize. Basically it's a classification problem, if you see, right? And classification in the logistic regression, we can use whether it's a yes or no, it's a spam or non-spam, right? And that email data could be used. Now here we are not supposed to read the email, but maybe some kind of signals it can read. It can filter based on some metadata of that email, some kind of hash basically, maybe, or some kind of how frequent our email is going through, right? All those things metadata could be used. And yeah, so here machine learning become important because the data started become available. It is because we were now collecting the data as a specific process. And during this time the internet has also evolved, right? And so internet helped the people to collaborate and build that kind of data, and machines could learn from the examples. After this, there's an era of neural networks, right? During this time, right, if you have seen when machine learning was picking up, during this time, deep learning were also picking up, but it was not that famous. But the mathematical concepts of neural networks return, right? The concept of perceptron was evolved very long. If you remember, in the first during the start, like we talked about, there was some researcher which came together and built the concept of a perceptron during the 1958, right? And this is the basic very smallest unit of neural networks. And then in 1986, what happened? Back propagation algorithm was emerged. Now this is very important. So if you might have seen, just let me give you some kind of examples. We have these neural networks, right? Let's say I'm building very small. Okay, so there can be some connection, right? There will be so many connections. Now, in neural networks, what happens? Uh, so this is one perceptron. It has some input and it has some output, right? And so likewise, each node is one perceptron, and they have some weights, right? And these weights initially assigned with random, and then when the data comes, when we train the this neural network, we use this backpropagation algorithm whenever there will be an output, right? Let's say, and that output basically says it's a right output or wrong output. Based on that, these weights change, and these weights change from here. What to update? Basically, a loss is minimized. Like, when we go deeper in neural networks, I think we will talk about it. But here, I'm keeping it at a very high level. Those weights are losses are minimized, and then those weights are updated, and that mechanism of updating those weights is called backpropagation, right? Those weights are changing from the back, uh, and this made possible neural networks to work as we are using today, right? And this is very important name, Lee, and there are a few others names which came to evolve this field, especially the deep neural networks, right? Deep learning. And then in this, like, what happens in neural networks, we have weights, we have neural network, then we do some kind of prediction, we compare the correct result, adjust weight, right? This adjusting is called backpropagation, right? And then we improve these weights, and this process continue, and this process is called training, basically. right? Neural networks were old idea. Mathematically they were old, but when the internet came, it has generated a lot of data. And when internet came, the cloud concept also came, right? So this during the around 2010 and all, right, the cloud computing become very famous. AWS, GCP from the Google, Azure, all these were coming. They were making the data available, and also to process they were providing the compute. And compute on not just the CPU. And one important company, which is Nvidia, they were developing GPUs. So GPU is basically a kind of CPU but very fast, right? And previously, when GPUs were not there, multiple CPUs were connected in cluster. Let's say there are so many computers um, which are connected, right? And whenever there is a problem, it try to break that problem to the smaller problem and give those sub problems to these different computers, solve the problem. After solving, they collate the data, and then they basically do something, right, with that final response. So this was a kind of parallel programming or parallel computing was happening before, right? But then GPU came. It made things so easy, so fast, that neural networks become viable to try out, right? So this was one of the important phase, which has changed completely the AI, what we see today, the real benefits. and and I was studying at IIT Roorkee during that time, and so we were having some professor who was working on this parallel computing, Hadoop kind of things, right? They were connecting all these, and then I remember the Nvidia company came to our colleges and they talk about the GPU, and they talk about how their memory was so distributed, and how they can basically write program. They used to call CUDA. CUDA is basically their programming a developer tool, or developer basically programming language. It wasn't C, C plus plus, I think C. So we can use programming on the GPU. GPU has a lot of cores, lot of memory. Each there's some global memory, there's some local memory for each core, right, to solve a particular problem. Just like this was a very big system, cluster kind, but all this can be put it into the one chip, one GPU. Definitely very fast and very optimized. So uh, yeah, um, during that time, it was just evolving, right? And we were excited, okay, how we can write these type of code, and it need to be in C or C++ because it need to be very fast and platform specific. So yeah, during that time, what happens? Uh, we learn the features automatically here, right? If you see in traditional machine learning, what happens, there are some feature, there is some data that people create, but that data was generated by the users. We need to provide what are the features and what is the particular field where we have basically output, right? In that scenario, um, we need to define the feature. As an ML engineer, you need to define the feature. But in case of neural networks, it automatically picks what are the features which is important for a particular problem, because it detects the patterns. It break the whole data into the smaller perceptrons, and each perceptron, let's say, focus on a particular very simple aspect, right? Let's say there is a face, right? Then a particular face, there is some nose, there is some eyes, and different parts of the body. All those, each node, I'm saying intuitionally, each node can focus on one particular aspect of that particular face, right? So some may focus on eyes, some may focus on mouth, or cheeks. That's why when we solve some kind of problem in computer vision, like whether images of dog or cat, right? So it basically just try to see intuitionally. Let's say there is an image, and that image have some kind of features, right? So it focuses on a few things and try to say a particular image is of what. A dog has different types of feature, a cat has a different type of feature, and all these features contribute to the final output to say whether a particular image is of dog or cat. Okay. So this is all about deep learning. Actually, this was sixth era, and here this was the time when it was growing. And here I already talked about because the internet, better GPUs, training methods, backpropagation, and all that got developed, um, and that what basically we can use. We can start using that. There was a large data set which got generated. There were some kind of open source frameworks which were coming, right? Improved architecture, all that were coming, and that's why the deep learning got famous, right? So LXNet for images, it was an image classification, basically a dog, cat, right? All those models were coming, and this has changed fundamentally how computer vision problems were solved, and that bring lot of interest again of the researcher to invest time and energy in this and build different types of experimentation, and that got lead to huge breakthroughs, first in computer vision, then natural language processing, NLP, where the traditional methods, basically it's a deep neural network or kind of a paradigm. Consider it paradigm is how the brain works. We are using the same kind of techniques to different types of problems. There will be some tweakings will be required for each type of problem. So for computer vision, there is an image, and if you see the image, it is two dimension. Right? There is a x-axis and there is a y-axis. So when there is some object, we have to see in both the direction and then see if it is matching a particular dog or cat or something, right? So it can't be just row wise, right? If we see the data in a row wise, it will not give a particular data. So what we can see in small chunks, right? Small, just like these small chunks means the small squares. We break down the whole image into the very small squares and then analyze each squares and then correlate with top, down, left, right blocks, right? And then we can consider a particular thing and try to recognize that. But in case of language, things is a different story. We will talk about it at the bottom. Okay. So here comes deep learning change the AI. And we have pixels, we have edges, we have shapes, objects, scene understanding, all that what I was talking about here, right? There was image, we have pixels. If we go pixels row wise, it can't make sense, but we have to connect small blocks, basically small shapes, and this is how we are recognizing this and making some sense of that particular image. So during that time, basically, large neural networks started coming, and it required a lot of computing. Computing means a lot of mathematical calculations. It all these calculations was not possible with a single machine. We need to do have large machines and cluster, or we need to have something called GPU, right, which can process so much computation in parallel, and we can have better computation. Basically, if you see, the GPU initially came for gaming because it required a lot of rendering, very fast rendering of the images and all, or videos. But as the GPU got traction, we can solve these large calculation in a small time. So this started building the neural networks on a large data. Okay. After this, what came is computer vision breakthroughs, which we already talked about, a kind of thing. So previously, only just the neural networks were coming, and now we have different types of problems within the computer vision. We have image classification, object detection, face recognition, segmentation images, medical imaging analysis, right? Autonomous driving perception, CCTV analytics, OCRs, document understanding, what it is. Basically, these are the different types of applications of computer vision. And when we are saying computer vision, what means whether a machine can see just like a human see. Right? And for seeing purpose, basically we are taking different types of images or kind of videos in a 3D, and that's how we are collecting that data in a computer form, and then we are passing that data for the machines to understand and identify whether a particular image is of one type of class or other type of class. We are detecting whether there's an object or not, and what type of object, identifying that object. We are detecting face, right? So we are detecting image segment within this particular image. There are multiple objects, and so we have to see how many objects are there and what are the where that particular object, whether it lies on left side, right side, top, bottom, any corner, all those things, right? Similarly, in medical science, like we can detect whether there's a tumor or not, or there are some the specific disease which is happening, or some kind of insights which normal human eyes take a lot of expertise. A very senior doctor or senior professional can understand those imaging, but with if that knowledge or can be transported to computer vision any machine, then that device can be handed over to a less trained doctor or very junior doctor, right, or some professionals which can help in understanding these kind of analysis. And these are the different models which came. When we study about computer vision specifically, we will talk about these things. But right now, just consider these models, and LeNet, LXNet, BGG, Inception, ResNet, YOLO, you only look once, right? And Mask, RNN, RCNN, Vision Transformer. This is one of the recent advancements in the last few years, and which is making a huge success in computer vision along with the LLMs, because images can be generated now, right, with the LLMs and all. So vision transformers, which is part of the transformer NLP extended version of it. Okay, so here what happens? Large scale image recognition. Now we can build some kind of systems where cameras can see and build some kind of data driven visual intelligence, right? And then reinforcement learning, this is another branch basically of AI, where we are learning with trial and error. So basically this is more of used in kind of robotics, but also uh, recommendation systems. Why recommendation system? Consider like you are shopping on a Amazon, and you might have browsed a product sometime before, then it still start showing those products. Or if you are buying one object, then it can start showing some other products which is similar to it. Like when you are reading a book, you are ordering a particular computer science book, it can start showing other computer science book which is very popular or of similar nature. Or if you are ordering, let's say, cricket bat, then it can show balls also, or wickets, right? Why? Because it understand there is a correlation between these two type of objects. If a particular person is buying us something, then it can, or it may need, or he or she may also need some kind of other objects. Like cricket with bat, we have a ball also, right? Or in robotics, basically, when robot is learning about something, it it do something. If it succeed, we will reward it. If it fails, we will give punishment. So there are few terms basically in reinforcement learning. We have an agent, which is basically someone who's learning with the reinforcement learning. And then environment, what are the factors, right? And then we have reward or penalty. If model while training uh, provide right output, it will get reward in a form of more weight is given, right? If it got a wrong output, then it will have penalty, right? So those kind of systems will be there. Then there is an agent improves strategy, and this is how the agent improves the strategy. It will do something. If it got rewarded, it will do more of that kind. And if it got penalized, then it will try to avoid that to some degree, right? So this is how the learning is happening with the strategy. And you might know the alpha goals of computer program of deep neural network uh, created by Google, right? It has a kind of top level go players, right? And then so yeah, so it is basically about pattern recognition, how agent is working, and that working basically help in identifying what is working, what is not working, and accordingly the reinforcement learning try to do it. Uh, these are the techniques, the small techniques, but this is not just only for these basically problems of recommendation agents or robotics. These are the techniques which can be used wherever it works. For example, recently when LLMs was getting created, but they are fine tuned or they are learning. So they are learning with these type of techniques also. So they can learn better. There can be a phased kind of learning, and when retraining is happening or fine tuning is happening, we can do with reinforcement learning. ठीक है. Now we will move forward, and this phase is about NLP before the transformers. So during this phase, right, what was happening? NLP was developing, but this was before transformer. Transformer is one of the important research paper which came from the Google, and that has shifted whole direction. It was transformer is basically based on neural networks, but it has few important keywords or techniques basically which change how it is working today and how the LLMs evolved after that. So NLP before that there were some rules, there's some bag of words, basically natural language processing. What is the purpose? Um Whatever the language with the people are talking, like let's say I'm speaking Hindi or English, right? All those words will be some bag of words, right? Whatever, for example, this sentence is written, but it is what a bag with words, right? All these words are different, right? So we were finding those bag of words. We are doing some pre-processing, and all those techniques we can talk sometime later when we study specifically about NLP. These are the different LSTM model, RNN, sequence to sequence attention. All these are basically neural networks. Attention is kind of mechanism which is used in the transformer, kind of self attention. But we will talk later around it, right? So this phase, NLP was developing. A very small chatbots were being developed. A basic understanding of the text which was given or a document was developed. It's not that accurate. Just like you ask a question with ChatGPT today or a Gemini, it returns an correct output. Whatever if the data is available to it, it may hallucinate, but that's a different story. But most of the time it is giving the right output, right, on the data on which it is trained. But that kind of analysis can't be done before the transformers, right? And then yeah, so we have neural probabilistic models, and then we are trying to represent a language, right? So you might have seen, right, in Three Idiots or Three Idiots, or I think PK, sorry, and there is a PK movie, right? And then the actor, the Amir Khan, says acha, 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 right? So acha means acha hai, ठीक है, but it has different meaning based on the context how we are saying. So the same word but different meaning, it because of the context. You were seeing me or seeing that actor, that's why you were recognize the tone, what the acha mean in a particular thing. At one instance says okay he got it, right, I got it, okay, a particular topic, right. And sometimes acha आंखें दिखा रहा है ना. तो in during that time what it says, acha means he was showing like threat. Acha, oh you can you are seeing me, right, some kind of thing, right. Or sometimes acha means you are able to understand. So and sometimes you are saying okay good, acha good good good, good work, right. So based on the previous words or after words, you are able to make sense of that particular word, what it means, right. And every language of the people, whether it's going to be Hindi, English, French, German, they have this kind of understanding, right. So it was struggling because it was having a long context. It was able to forget early information. It need to have the whole thing when it is focusing. So that's why the attention mechanism when came it become a very solvable problem. There will be some task specific trainings, right. And then slow to run. Previously GPUs was not there, so it was slow to run. This was the about NLP. It was just considering, uh, basically trying to represent language as a vector, a form where computer can understand, a machine can understand, right. So the previous the stages helped in representing the knowledge in a way where machines can understand. And that's why when everything came together, the data, the compute, the representation, now the explosion of the real AI, because it is able to understand the patterns. Those algorithms, those mathematical models were created long time back, but conditions were not um, good for coming all the things together. But now things are coming together, right. So we will see later in the Gen AI course, we will see the embedding, semantic search, RAG, LLMs, vector database. We'll see all these keywords and meaning what it takes, right. फिर आता है अपना जनरेटिव एआई बिफोर एलएलएम्स अगेन. जेन एआई बिफोर एलएलएम. एलएलएम वाला एरा क्या है जो अभी का एरा है, जब हम डिफरेंट डिफरेंट मॉडल्स देख रहे हैं. जेन एआई जनरेटिव एआई है. जनरेटिव एआई मतलब जो चीज़ें जनरेट कर पाए. द प्रीवियस मॉडल्स वर एबल टू, what they were doing, they were able to recognize a pattern. There can be a predictive kind of analysis, right. But this is able to generate something, generate some new thing which it has haven't seen before. But it will generate based definitely on the patterns of what it has seen before. But again it is generating with mix and match of different things. So AI started creating a new content. That's why this era is important. Here, first GANs came in the form of images, right? And all these autoencoder, variational autoencoder, basically, right? And then diffusion models, transformer-based generators. Transformer initially came for NLP, and then Vision Transformer came, which is able to generate images. And GAN is kind of a generative adversarial network. It's a basically kind of, there are two important terms. Generative, first thing will generate an image, this module, and then adversarial will check whether this image is correct or not. You mentioned data image of a dog. Now this component module will try to generate an image. This will check whether it is correct or not. If not, then it will give an error, and then again it will try to generate and try to reduce the noise, right. And then diffusion models, we will talk about in more details around these, but these are the models for computer vision, okay. uh, then this is how the Gen AI started with computer vision first. right? And then here I talk about the generator get a fake image, discriminator try to check whether it's a real or fake, generator improve, discriminator improve, right? They will try to improve each other, give a feedback basically, right? And this shows realistic images, faces, synthetic data it can generate, right? And then recognizing content and then creating content. Previously it was just recognizing content or doing some predictive analysis, but this was gen ai. This is how it started. Then the phase came, what we were waiting, transformer. This was a research paper, attention is all you need, by google. This was a research paper which changed the things, how it was working before. NLP change, it started with NLP, major limitation of older NLP, right? Basically, it was able to have the large context, long sentences, long paragraphs. It can consider everything and then focus on each. That's why you are able to understand the meanings of different acha, or acha. So there are different meaning. But that word itself has no meaning, has a meaning, but in and around whatever the text is there, it will give better context and have the understanding of the NLP actually, right? And then there's a parallel trainings, large scale pre-training. So when LMs got generated, you require lot of training. Basically, all the data which is important, good, we need to first represent and then train the data. So any LLM, you can't go ahead and then create your own LLM. um, uh, at least the pre-training. Pre-training is a one first phase, right, where we just train with the raw data, um, with all the data which is available on the internet as much as possible, with the proper refining, clearing the data. Um, that's why it's very costly and compute-wise, right? That's why India is not in a position to create right now its own airline, or it failed basically, it's not succeeded um, the way other countries have succeeded, like the US and China. So what we use, we don't pre-train the model, but we fine-tune the model. We can fine-tune. Fine-tune is very cheaper process compared to the pre-training. It can have better translations, better text generation, later development of LLMs, and this is transformer later become one of the founding stone for building the LLMs. And attention helps. Attention, how it helps? Because it can focus on other words, right? The words which matter most for understanding the current word. So there is a word, because it was tired, right? Animal did not cross the road because it was tired. Now if you just see it was tired, you don't know who was tired, but you can understand whether that was an animal or not. If you see everything, then it focuses, okay, this word is focusing more on this, right? That's how it is able to understand it means animal in this sentence. Then we have transformer is one of the most important invention in modern AI, definitely, right? After transformer, AI research shifted from task specific to large pre-trained models. Now these are called foundation models, because once a model is trained, it is not retained or limited to that particular problem. It can be used for many other problems. Like LLMs, we can ask question, we can summarize things, we can do lot of generation, we can do lot of things with LLM, and we can fine tune it for a particular specific things. So these are called foundational models, right? And similarly, we are trying to generate foundational model for computer vision, where it can understand everything around it. We just can use that model to for general purpose use cases also. Some efforts has been made, but still it requires some kind of more work. So after this, we have got foundation models. Yeah, here it comes. Foundation model LLMs that got generated after 2018, and these are the important milestone. BERT model came initially, then GPT-3 from OpenAI. ChatGPT came. It's a flagship model, and then 2000 late 2000 2022, uh, ChatGPT become famous, and then since then so many different companies which came along also for developing a better LLMs. LLMs is used for basically writing something, summarizing, translate, writing code even, right? So this is one of the specific use case. LLM is foundational because it understands the language, but it can generate the code. We don't have to retrain the whole model from the code, but we can just fine tune that model for generating the code, right? So that's how coding agents are coming. We can explain, we can reason, classify, all this different use cases can do, right? And then we have train one model for one task. This was the previous story. Now with LMs, we train only one large model. We use that model for different purposes. That's the story which is started with this era. After that, we have the diffusion models, which is in image generation in computer vision. Basically, diffusion models is a different approach for generating the high quality images. What it does is start with noise, right, and then remove the noise step by step. So you might have seen a blurry image, or not blurry, just everything is like noise, right? Some dot here, all the. Then we say, okay, now create a from this out of image of a dog, we'll try to remove some noise, and after removing a noise we have some kind of dog, right, and then maybe some other still a lot of noise. Then we will try to further clarify it, then till we will continue this process till we are having a good image of dog, right? And based on this technique we have different models: the dolly e, stable diffusion, mid journey, fireflies, image chain. Diffusion is a technique basically, just like the transformer, right? And then diffusion is here. GAN made generative images popular, right? With GAN, basically generative adversarial networks, we were able to generate images, but the images were not very clear. But diffusion models, we were able to make that possible, and we can also use text from write the text, and then it generate an image, or we give some images, two three images, then we can collate those images, or we can combine that image, right? We can change. So all that is happening with diffusion models. It has shifted the direction how the design, artworks, ad, right? All these things are changing. Marketing content, right? All these things, how we are generating images today, it is because of this diffusion models. After that, we have vision LLMs, VLLM. What it does, it has a language component, it has a vision component. When we are training the LLMs, we are also using the images data, right? Or with this we are going to the multimodal. You understand this term? Multimodal means multi and modes. Modes could be images, text, voice, right? All these are modes. So we have VLLM. VLM is vision LLMs. It has the images layer. And with text also, we can generate an image. And with image also, we can generate a text. It's a vice versa. We give a text, generate an image of a dog. It will generate an image of dog. Like when then we can say we give an image. We say convert this image along with my photo, right? I can give my photo and then it can combine my photo within that, so image to image. It can also, we can give an image and say write the description of this image. We haven't seen that image, but it can generate a text of that particular image, right? So from image to text, you got it, from text to image. We have an image and multiple images. From that we can get one image. We can have image and we can generate some description of it, text based basically, right? So we can have multimodality, and multimodality is mean from here to here, but at least it at the same time it can consider different types of inputs. Some input could be of text, some input could be of images, input could be of voice also, right? But this is not in the vision VLM. For voice we have different types of model, and clip is one of the very important model in this VLLM part. How the OpenAI created this model basically, and they take images and text pair for training the data, for training their model. Sorry, right? So they have this type of data. It has an image and text, then so that it is able to represent and understand both type of knowledge. And when we say multimodality, the inputs could be of different type. There could be images, text images, screenshots. Again, this is an image, diagrams, charts, or different types of charts. We can have some kind of document. We can have audio, video, everything, right? And as models are becoming more important and more powerful, all these things are happening. These are some of the important models in the VLM, GPT-4, 4o, style like Gemini family, Claude models, L Llama, right, and Flamingo, Blip, Clip. All these models are of VLLM. We talked about this is a shift that happened, right? Previously, model was only of one type. Now it is taking language along with the other types of input. So basically, whole world information is coming together. Now we came to the open source model, and this is basically previously big companies. It required a lot of data, a lot of compute. So big companies only investing, and they were able to generate first set of these models. But later on, the universities and some other companies came, which has open source these technologies. Not the best model of their companies, but at least some models, so that open source community can build on top of it. Because once a model is created, which is a pre-trained version, after that you can fine tune it for a specific purpose. So this is how the things were changing. And then Quine model, right? And then DeepSeek, which came from the China. It's a Chinese company developed this, and it is also open source. And this model basically um, created a huge shock in the stock market of AI companies, because this generated or trained model based on the reinforcement learning. You remember when I was teaching reinforcement ever? Uh, so they used techniques, but they used reinforcement techniques so that model can be trained in a very cheaper way, and it can use lesser tokens, and it is cheaper for inferencing also. And that made a huge shift. And then other companies like OpenAI and all, and Gemini, Google came and started using this technique as well, right? And then Gemma is Google's model, which is open source and have lot of data from authentic sources, so that the objective is to reduce hallucination and all, right? In 2024, Meta basically also created Llama 3 model with these weights, right? These number of parameters, and which is adding more strength to the open source models, right? Open source models are free. They can be used for research. They can be used for the smaller basically commercial purposes. But after a limit, I think Meta charges if the usage increase to a particular after a limit. But again, you will require your own compute. You have to run your own GPUs, so that model can run and have some kind of inference, right? And then AI become more decent, democratized or decentralized. not decentralized but really democratized, because open source communities started coming together, and they were also developing some kind of innovations on top of it. After that, context, the race of improving these LLMs started, where we have long context. Long context is basically how much input we can give to the LLM. Previously, it was just few paragraphs, right, and then or few pages. But now even a book can be given as an input. Of course, it will have a lot of tokens to process. It can have the problems of context rot. It can have higher cost of processing the huge book, but it can, if there is a need, you can give a large context. And then there will be some different types of techniques also to solve the problems of context rot and all, right? We can give long PDF, we can give long code bases, research paper, legal documents, so many things, videos. This can be done, right? Now the shift was happening to the reasoning also. So we want to add some models where it can reason basically about the LMs, and then give the output. And reasoning, you might have seen paid models. We have reasoning where it can give high, low, medium or low, right? Now, so what with this reasoning, what it does, it try to see the particular query and then try to break it down and plan it. It can take more time, right? So this is happening with the very large models also, to give the better outputs. After that, we have RAG and enterprise AI. Now, all these developments sorry, after LLMs, these are the to improve the LLMs and to improve how the AI work and the agentic things work. LLMs, basically any model is trained on once. It can't be trained on the latest data every time on everyday basis, right? There are some things which is happening, or there are some company specific documents which can't be shared for training, or there can be some kind of proprietary data or some knowledge bases. All that can be used for your system, and this is basically a technique called RAG, retrieval augmented generation, right? Which means basically it helps to basically retrieve the right information from those proprietary information or the data or the policies, whatever you have from the databases, and then give it to the LLM. LLM, along with its own prompt, it can use that data to generate a better output or whatever you want to achieve with the help of LLM. And this also raised to the rise of the agentic AI. Right now, LLMs become powerful because it understands the language, it has the data, which is proprietary, which can't be shared for training purposes. So it can be used along with this and can run in loop, multiple iteration. And we'll talk about agentic AI maybe in some other video. But RAG is an important part here, right? And then we have AI agents. So let me finish that, right? What is AI agent? There is an LLM, right? And then LLM, after it predict whatever the output, it checks whether it is achieved its goal or not. If not, then again go back to the LLM and then try to predict again, and then with some more information pre-processing. Once this is done, then it will exit, right? So agent is basically something which is having an agency of decision making. It can make its own decision whether I have to continue or I have to exit, right? All that thing is basically for the AI agent. We use LLM. Definitely, tools are the basically specialized techniques which we can provide to the LLM. LLM can decide whether to call a particular tool or not. Right? We have some memory when LLM is running for a long time, or it need for long different types of sessions. You asked one question, then you ask another question. So LLM should know its own previous data, right? All that data is important, and that's how it is becoming, memory is becoming important. So it should understand what you already talked about before, right? All that thing is important. ठीक है. Now that it can do some kind of planning when we have long running tasks, right? This is Claude Code, Claude Cowork, you might have heard. अब ये क्या करते हैं, दे दे कैन टेक वन टास्क, plan it, break it down into multiple tasks, right? There is one query which came, right, and then it planned to different small tasks. They do these tasks one by one, and if needed they again update the plan. All that thing is happening, and these are the long running jobs, right? It may take hours even, right? These coding agents that you write code, it may take 5 minutes, 10 minutes, 20 minutes, but once they are done they checks whether their output is achieved the objective or not. If not, then they go back and then fix the error and then again do something more, R&D, and plan the task and complete that task. Once done, then they exit. So all that is possible with the help of agent, and all these things are, that's why comes in the agent, right? They can call API access, they can call the APIs, let's say weather APIs or the financial banking API. They can call. They have the computer use or browser use. They can basically, they have got the permission to open a file in your computer, save the data, retrieve the data, create a Word document, create a PPT, right? All those things can be done with the help of these agents, right? File handling, workflow execution, all this is part of the AI agent. When we study in detail, we'll talk about all these key terms also, um, right? And how these are used: coding agent, research, customer support, sales agent, data analysis, personal assistant, document automation. So many things are possible. Okay. Now we have physical AI. Physical AI is basically about the robotics, how Chinese companies, have, like Unitary is generating so many good robots, right? And for the same reason, Galgodia University came in highlights because of using their product. So that is also an AI, right? But it is using these understanding of the language, one part, but they are using reinforcement learning, right? So we are, when we are saying humanoid robots, like just like the human, they do self-driving vehicles, BYW, like BYD, or this Tesla. All these are self-driving, right? All these things are possible. Robotics. We have some robots which is working in the Amazon factory, or right, to collect the things and then put it at the shelves and then use in production. So many things are AI in warehouses. It is happening in cameras. We are using medical robots for doing surgeries, even, right? In within the industry, we have simulations model, right? So all these things are happening as part of this physical AI robotics, uh, right? And people are try to build these models where AI can basically see, including the computer vision, understand language models, plan large language model, deep learning, right? They can act, they can have some kind of reinforcement learning with they can signal basically the model to do some kind of work with the physical thing, learn about the environment, right? So reinforcement learning. So different techniques of machine learning coming together, or AI coming together to build pet products, right? So yeah, so these are the different phases, 19 phases we talked about. So much of things we have talked about here, and it could be overwhelming. So don't feel overwhelmed, I would say, because these are the different phases. We try to cover how the AI landscape looks like, how the AI shifted during the 1950s to today's time, what are the different phases came, what are the different types of AI, and different milestone which has shifted the direction. So when you focus on a particular thing, you will go deeper in that particular phase. For example, you want to learn about the Gen AI. Then you will learn about mainly for LLMs, agentic AI, and all, right? If you study about computer vision, now then you can study how the images works, and how that computer CNN and these foundation models for vision, VLLMs, all you will talk about and read about all these things. Maybe in future videos we will talk about all such topics, but here we have this much. I hope you got fair understanding how the AI is developed over a period of time. It is just not with chat gpt कि भाई चैट जीपीटी आ गया, नाउ एआई आ गया और अब दुनिया बदल रही है। दुनिया पहले ही बदल रही थी, अभी भी बदल रही है, अभी थोड़ी तेजी से बदल रही है, बिकॉज एआई ने हर चीज को ओपन कर दिया। एआई एक काइंड ऑफ न्यू इलेक्ट्रिसिटी है ना, जहाँ पे हर चीज पे हम एआई लगा के कुछ चेंज कर सकते हैं। तो इसकी वजह से चेंजेस बहुत ज़्यादा हो रहे हैं। यू हैव टू लर्न इट, यू नीड टू अंडरस्टैंड इट, यू हैव टू मैप इट कि मुझे अभी लर्न क्या करना है। सारा एआई तो पॉसिबल नहीं है, आपको इवन पीएचडी भी करोगे तो आप एक पर्टिकुलर फील्ड में जाके डेप्थ में करोगे। बट एटलीस्ट हैविंग द अंडरस्टैंडिंग, हैविंग द माइंड मैप कि कौन कहाँ कैसे काम कर रहे हैं, कैसे इवॉल्व हुआ, विल हेल्प यू एंड कीप यू मोटिवेटेड इन अ पर्टिकुलर डायरेक्शन दैट वेयर यू आर गोइंग एंड व्हाट यू आर डूइंग एंड व्हाट यू आर नॉट डूइंग। ठीक है। So with this note, I'll take a leave. This is a very long video, but try to see it full if needed. See it in fast pace, and share it with the friends and other students who may be finding this useful. Like this video, give a thumbs up, comment on this video so that it can reach to the students like who want to learn about the scope of AI. I hope I have done the justice with this. If there is any mistake, I'll really sorry. Please let me know in the comment section, and I can improve on these aspects. With this note, I'll take a leave. Thank you. Bye.